Hi, welcome to this quick demonstration on square wave voltammetry. So in front of me I have a SIA Potentiostat, and in fact what I'll do is I'll just get that solution off just to kind of show you the workflow. So you can easily take screen printed electrodes in and out quite easily on this particular device. I think this is by far the best designed way of inserting sensors into a potentiostat. I'll put the solution on there again. Just the nice thing about electrochemistry is it only takes something like 50 microliters just to cover those electrodes. It's probably worth saying that ZP does do contract development, contract manufacturing of biosensors, and we do know how to kind of bring the biosensors in a nice form factor that it's easy for things like, not things, people rather, like doctors and nurses to handle. I'll actually go to my settings, which look fine, and then I'll start the measurement. Now we do design our assays to be quite fast at ZP. This is just because we know that really, I don't want to say, people who in the real world want to get results, they don't want to wait around for the voltammetry, so we are doing this fairly fast. Now at the end of it, we get an upload complete on the phone. Now what upload complete means is if I just go to my screen here, all the data's actually gone into the cloud, so I can see my experiment here, and then I can see my voltammetry here. This is when this system starts becoming kind of into its own, if I can put it that way. What I want to do is I just want to show you that we've got a tools bar here, and then we can start playing around with parameters. Like what I'll do now is I'll just essentially playing. I'll go pre-processing, and in fact what I'll do is I will do a moving average. We don't particularly need this because the data's quite good, but I just want to kind of show you that. I'm just going to do a quick bit of smoothing on this data. You may have noticed that that menu was actually quite extensive, but here we've got the raw data. Now I've done a bit of pre-processing on that data. It smoothed it out a little bit. Now you may need to do this in the real world when you've got real data. And then something else I can do under, let's say, pre-processing, just go in here, is, for example, I think I need to actually add a bit of a baseline. So I'll explain that in a minute, but what I'll do is I'll do a baseline adjustment. And what I want to do is I'm just going to put in some values here. Let me say 0 and let me say 200. And let me just close that down. So what that's done now is, rather than having my kind of current up here at sort of 12 or about 13 microamps, it said, no, this is the baseline. This is my baseline for my signal. And it's brought that to 0. So you can see it's done that automatically. And it knows what I've done, if I can put it that way. And then I'll just show you another feature, which is I'm going to show some extractive values. I'm going to do peak height, and I'm going to look for a peak. I think that peak was about 200, and I'll put 100 on here, and I just want to check it. I'm going to just put a sensitivity of 1 and essentially no intercept here. I'm just fitting it to a linear equation here, by the way. I've got all sorts of opportunities, or options I should say. Let me just have a quick look down at this. Yeah, this is not too bad. So what I've done here then is I've done a quick demonstration of square wave voltammetry on a very elegant, easy to use, probably the most productized, I would say, least, and when I say least scientific, I mean in a very positive manner. This is a very elegant, little instrument, something that a doctor or nurse can use quite readily. So you can really achieve the MVP. Runs smoothly off my phone, and then has a very powerful back end to it. So I grabbed the raw data, I've smoothed it, I have also done a baseline extraction. I've also then found the peak height, and I've fitted it to a very simple equation. In fact, I know that this solution is actually 5 millimolar. So what I want to do now is I just want to try this, just a little bit of fun, 0.9, and let's have a quick look at that. Yeah, so if I adjust that 0.9, I might, if I make it 0.85, let me just see if I can make that 0.85. See, I probably need to change that a little bit more to actually bring it closer in. Yeah, it's getting closer now, so maybe Do I go to 0.75? I'll just do that just as a bit of fun, but then I should really stop because otherwise I want to show you one more thing. So please bear with me as I want to do one more thing now. 0.75. Yeah, I went over. I knew I should have done something like a 0.8. Maybe I'll just try that just real quick. 0.8 done. Right, 0.8. So I can basically go from raw signal, smoothing, baseline extraction, fine peak, fit peak to simple formula. Simple formula will then convert the peak height in this particular example to millimoles. So that just gives you a quick idea of the utility of this. I want to show you the real power for this instrument now as well. So what I'm going to do is I'm just going to go back to this screen. Bear with me. Right, so I've got my instrument here. I've got my app. I just want to scan a QR code here. So I'm just going to do that. Right, so now I've scanned it. So what I'm going to show you now is how you can actually then use this same instrument to give a very kind of a very good customer experience. So I'm going to actually take some sensors from over here, put those in like that. Right, I will take a sample. This is the beautiful thing about electrochemistry. This is a very kind of slightly grimy sample, if I can call it that. It's got bits and stuff in it. I will put that onto the instrument. Which I've done. I'm just going to give this a name so I can find it in a bit. Right. So this is in this particular mode, I actually moved it into, I say chili, it's really measuring capsaicin. But it's just showing you how we can actually go from kind of fairly simple lab procedures and actually turn it into much more of a nice user experience. In this case, we've actually chosen to actually send the concentration back to the phone. So understand, it's really just done voltammetry, but this time we went a bit further in the customer journey and actually have given them the concentration on their phone. But at the same time, I still have all the benefits of that I was describing earlier on. So if I go up to here, I go to reports, I do a quick refresh here. I can see my data here. And it's kind of, I've done a sort of similar thing to earlier on that, you know, we've got the raw signals and I can see here that we've gone and found a peak and we've fitted that peak to we've done some low pass filtering here. We've been flipping it. We've been doing cropping on the y-axis. We've been finding the peak. We've been fitting it to an equation. We even told it how much we diluted the sample by, and I should actually get myself out of those images. But what it says is, yes, this device can do square wave voltammetry. Yes, this device can do a quick measurement on the square wave voltammetry. Actually, it does it all off the phone. We send all the data straight to the cloud. Then we can start opening up this data pipe in the back end. And in this particular case, we've actually even chosen to send the data back to the phone. So you can really appreciate that if you're developing a product with this, you can give a very nice user experience really quickly. And there was really no coding required in order for me to do a lot of data I won't call it manipulation, but data cleanup on that before actually turning it into a signal. So I think it's, or not signal, rather final concentration. So I want to say, if you've got any questions regarding square wave voltammetry and this particular potentiostat and its capability of actually becoming a minimally viable prototype, then don't hesitate to reach out to us at ZP. Okay, thanks very much.